Hi, I'm Paul Bailey. This is part of the introduction to PIAC. We'll be talking about sampling design, weights, and variance estimation, and how those are important to properly using PIAC. The PIAC population is non-institutionalized adults aged 16 to 65 who reside in the country at the time of data collection, irrespective of nationality, citizenship, and language status. This is then limited to residents who live in a house, an apartment, a condo, and workers' quarters, halfway homes, dormitories, fraternities, and sororities. That excludes prisons, hospitals, nursing homes, and military barracks and bases. Adults with hearing, vision, and physical or language disabilities are in scope, but they have limited information, background variables, and cognitive skill values. Countries were further allowed to oversample and include additional subpopulations of interest, and many of them did that. PIAC standards require a probability-based sample, which is why we're going to have weights. And most countries implemented that with a multi-stage stratified cluster sampling design, but some used a single-stage design, as we'll talk about later. And the PIAC sample design was at first self-weighted, and what a self-weighted design means is that every person in the population has an equal probability of selection. When you have a self-weighted design, weights become extraneous. But in fact, many countries also implemented oversamples, which makes it not self-weighted. And the PIAC conferences in Germany, so we're going to talk about them a lot today. And in Germany, the coefficient of variation for weights was about 0.3. This is actually relatively low for PIAC cycle 2, where the median coefficient of variation is 0.63, which shows that the designs actually did include oversampling. And so we are going to need to account for weights as we analyze PIAC. There were several types of sampling frames that were used for PIAC. It could be a list of residents, or it could be a stratified sampling design. Um, Participating countries varied a lot between using a single stage to even four stages when they were sampling. This is easier to use a single stage when it's geographically small. You're not traveling a great distance to sample a single person, and it's easier to use stratified sampling for a geographically large or difficult to traverse country. Um, Here's a list of countries that did a single stage design for PIAC, and here's ones that did a two-stage design. Although notice some of the first stages are households, so which is would in terms of how much time it's going to take to get to people's houses, or how in some ways this is like a one-stage design. But we're going to see that in the larger three-stage design, we're going to see oftentimes the second stage is a dwelling unit um, or a household in these three-stage designs. And then finally, there's the four-stage designs where there was a geographical area that was sampled, potentially a smaller geographical area, and then oftentimes households or dwelling units, and finally, people. Let's talk again about Germany. So they used, just to get specific on one particular case, they used a two-stage stratified design. And the primary sampling unit is municipality, so it's geography based. And they're selected probability proportional to design. Sorry, probability proportional to size, which means that larger geographic areas with more people in them were more likely to be sampled in this phase. This actually makes each person have an equal probability of sampling when you use this type of design. However, sometimes a particular unit will be a certainty, which means that it's guaranteed to be in the sample, and that would be a primary sampling unit or area. Um, Second stage, they sampled individuals. So this is a systematic random samples of individuals, and then some sort of neat tricks were used to make sure that they had balance within the country that you can read about on the slide. The sampling weights are designed to account for the fact that everybody didn't have the same probability of sampling, and they they compensate for the disproportionate sampling of subgroups. And we then use the weights to be able to estimate things like a national average while accounting for the fact that some groups were sampled more or less likely. We're also going to use the weights in order to get cluster robust standard errors or just robust standard errors for a single stage design. The PIAC final weights had many steps that we won't be covering all of, but it starts with the inverse probability of selection. So if a person had a probability of being in the sample of 1 in 100, they would start with a weight of 100. And so they said the weight is then said to indicate that they represent 100 people. A certainty would have a weight of 1. And of course, a person isn't going to be a certainty in a sample like PIAC, but an area could be. And those are called self-representing. The uh, after everything, after all the other steps are done, there's a post-stratification step. And in this step, the weights are adjusted so that the totals on specified characteristics, which would be available from a census or some sort of administrative data, can add up to the right answer. So if I know that there are 4 million females aged 20 to 25 in my country, I would make sure that my PIAC sample indicated that there were 4 million females aged 20 to 25 after I was done waiting. And that's what post stratification is. So these were based on a couple covariates. Age, gender, and region were used in all countries, and several countries also used other variables that are associated with proficiency, such as education, employment status, and nationality. Of course, your country needs to have administrative data on the level of these covariates in the country in order to do post stratification. But when available, it is a good variance reduction technique. Replicate weights are used for variance estimation, and they're another set of weights that we can use to re-estimate the population statistics and then use those re-estimates in order to get a cluster robust in the case of a clustered sample or robust variance estimate. How the jackknife or JK2 method works is R naught would be the full sample weight of the one I would use to estimate the population level or, whatever the population mean is. And then we would re-estimate it more than 10 times likely, but uh, we'd re-estimate it first using the weights R1, which set the groups in strata 1 or set PSU 1 in strata 1 to 0 and the PSU in strata PSU2 in strata 1 to 2. I can see that in the column labeled R1, and then we re-estimate the whole statistic all over again. And then we go back and do that again for R2 and so on until R80, oftentimes in the case of PIAC. And this is just the math for that. We estimate it says how we do this with labels that we're essentially going to estimate something that looks a lot like a variance, the difference between the estimate with a replicate weight and the estimate that we came up with the full sample weight squared, and we're going to sum that up. And then there's a constant that depends on how exactly the survey was or how the weights were designed. That it gets pre-multiplied by. And that ends up being the variance of sampling, which I've labeled VSamp. Just to review sampling weights, when people are directly sampled in a single stage, then the observations are independent. When people are sampled in a multi-stage method, then the observations are clustered, and we're going to want to use cluster robust errors, as we will in Ed Survey. And that's to allow us to properly account for the results from the sampling scheme. These sampling weights are required to get results that are representative of the target population and to account for demographic imbalances in the sample. finally, we can use these weights or the replicate weights to get cluster robust variance estimates. Thank you so much.